Okay, good day everyone. Welcome to our session on multiple linear regression. Today we will take a closer look at one of the most powerful and widely used statistical techniques in research. One that allows us to predict outcomes, explain relationships, and make data-driven decisions. Our topic is titled Understanding Multiple Linear Regression concepts, assumptions, and applications in research. This discussion will help you understand not only how multiple regression works, but also how to properly apply it in your own studies. Now, let's begin by understanding what multiple linear regression or MLR really is. Multiple linear regression is is a statistical method used to predict the value of a dependent variable based on two or more independent variables. In other words, instead of looking at one predictor at a time, MLR allows us to see how several factors work together to explain an outcome. It is especially useful when relationships are complex, when variables interact or overlap in their effects. And by modeling these interactions, MLR gives us a clearer and more realistic picture of how different predictors jointly influence the result. For example, in educational research, a student's performance might depend not only on study hours, but also on attendance and stress levels. MLR helps us quantify how each of these factors contribute while controlling for the others. Ultimately, MLR helps researchers and educators move beyond simple cause and effect thinking and toward understanding how multiple variables combine to shape outcomes. Now that we have an idea on what MLR is, let's take a look at its mathematical foundation or the model itself. So you could see here the equation for multiple linear regression. It may appear very intimidating at a glance, but let's try to break it down by part by part. So we start with the variable on the right, that is the variable y. So this variable y represents our dependent variable. This is the outcome we're trying to predict or explain. For example, if we are studying student performance, y could be the final grade. And next we have x subscript 1 or x sub 1, x sub 2, up to x sub n. These are our predictor variables or the independent variables. These are the factors we think that influence y. In our example, this could be study hours, attendance rate, or stress level. This will be our example, and we will have this in the succeeding slides. The beta sub zero, we have here the beta sub zero. This is what we call the intercept, and this is basically the starting point. the value of y when all predictors are zero, and it gives us a baseline before any predictors come into play. Next is the numerical coefficients. We have here the coefficients beta sub 1, beta sub 2, and so on. These are what we call the coefficients. These are really important. Each coefficient tells us how much y changes when one predictor increases by 1 unit, while all the other predictors are held constant. So if b beta, okay, so if the beta is positive, that predictor increases the outcome. But if the beta is negative, then it decreases the dependent variable. So design of the numerical coefficients or the coefficients is very vital. Okay, so kung positive yung sign niya, magdi-decrease, mag-i-increase yung y. But if the beta is negative, then we expect uh, a decrease in the value of y. And another variable that we should consider here is the epsilon. Doon sa equation natin, the last entry in our example, I mean in our equation, that is epsilon, or we simply call it the error term. And this captures everything our model doesn't explain. The random noise, or the unpredictable factors or measurement errors that influence y but are not included in the model. So these are external factors that may cause the dependent variable. So in simple terms, multiple linear regression helps us create a formula that uses several predictors to estimate or explain one main outcome. It's like putting together different puzzle pieces. Each variable contributes a part of the picture, and together they help us predict y more accurately. And now that we've seen that the multiple linear regression model looks like, let's talk about something just as important, the assumptions behind it. Think of these assumptions as rules of the game. If we don't allow them, or I mean, if we don't follow them, the results from our regression might look fine on the surface, but they won't really be trustworthy. Now let's go through each of them one after the other. So we start with the first assumption. We have linearity. Okay, this means that the relationship between each predictor and the dependent variable should be linear. In other words, it should form a straight line pattern. If the relationship is curved or nonlinear, the model won't capture it correctly. And to check linearity, you can check this using, of course, in the SPSS, you can use the scatter plotting. Use a scatter plot to determine linearity. Now, the next assumption is independence. This means that the residuals or the variations, the differences between actual and predicted values should be related to each other. This assumption is especially important when you have data collected over time, like in time series studies. If one error influences the next, your results can be biased. And again, to check independence, pwedeng gamitin ang SPSS. In fact, all of the assumptions can be checked doon sa SPSS naman. Pwede doon lahat. The third is homoscedasticity. This is a fancy word, simply means the errors should have constant variance. The spread of the residuals should be roughly the same across all levels of your predictors. If the residuals spread out more for some values and tighten up for others, that's called heteroscedasticity, and it can make your estimates unreliable. The fourth one is normality. This doesn't mean your data has perfectly normal, but the residuals should roughly follow a bell-shaped curve. This helps ensure accurate hypothesis testing and confidence intervals. And finally, the fifth assumption for valid multiple regressions that there should be no multi-collinearity. What is this? The meaning is that there shouldn't be two highly correlated predictors, because when two predictors are almost the same, it becomes hard for the model to tell which one is actually influencing why. So there will be confusion on which is the dependent and which one should be the dependent and which one should be the independent. And again, you can check this in the SPSS, particularly the variance inflation factor or VIF. Okay. Now to recap this, for MLR to give valid results, we need the relationships to be linear, the errors to be independent and normally distributed, and variances to be constant. And predictors should not overlap too much. Now, let's move to a sample problem. Okay, let us have an application of the formula. Let's look at how multiple linear regression actually works in practice. To make things concrete, here's a simple example. So we have here the data. Actually, the number of respondents is 80, kaya lang medyo kinat ko ito. This is the SPSS interface. This is just to show you how you should input in the SPSS. So nakat lang yan, mga 80 ito. Okay, so this, so syempre since research is a scientific undertaking, there has to be, before you undergo the experimentation or the research, there has to be questions or guide questions before you proceed with the experimentation. Just like in actual thesis or research, kailangan meron tayong research questions, or we can also call it the statement of the problem. So dito, the independent variables, there are three independent variables and one dependent variable, which is the final grade. So we start with the question, can we predict final grade using students' academic related factors? Now, the students' academic related factors are study hours, attendance rate, and stress level. This is among students. So we have here a sample of 80. Kaya ang sinabi ko kanina, nakat lang yung data natin. So the outcome variable is the final grade, and the dependent variables are, as I've said earlier, the stress level, the attendance rate, and study hours. So we start with the first step. Okay, so the first step natin, we identify or we conduct exploratory data analysis. Paano yan? Okay. So in the exploratory data analysis, we have here the steps to undertake. We start with the distribution analysis. Okay. So paano ito? Distribution analysis. During the distribution analysis, we check first how each variable is distributed. Is it normal? Is it skewed? Or does it have extreme values? For example, if we plot a histogram of students' study hours, we might notice that most of them study around 10 hours per week, but if you study 20 hours or more, well, that tells us something about spread and central tendency of our data. In other words, if you recall the assumptions, dapat doon sa normality, papasa yung data natin. It should pass the test of the normality test. Okay? So, yan yung activities under the distribution analysis. We check whether the data are normally distributed. Next is we check for outliers. Okay. So outliers are extreme values. So these are data points that don't seem to fit the general pattern. For instance, a student who studied 2 hours a week but still scored 98, or someone who studied 25 hours but failed. Outliers can be real or errors, but they can strongly influence our regression results. So it is important to decide how to handle them before moving forward. But usually ang ginagawa natin, if there are outliers, of course, the determination of outliers is not arbitrary, hindi depende sa tao yan. So we use, again, pwedeng gamitin yung SPSS, automatic yan. The software can detect which are outliers. So it's up to you if you want to retain them or pwedeng tanggalin. Pwedeng i-delete nyo yung outliers or you exclude them in the analysis. The SPSS can do that. The third is the relationship visualization. This is where we start exploring how our predictors relate to each other and to the outcome variable. So ang gagamitin natin is scatter plotting, correlation matrices, or pair plots that can help us see whether the relationships look linear and whether any predictors are too highly correlated with each other, which could indicate multi-collinearity. And take note that one of the assumptions is that dapat hindi multi-collinear yung data natin. So overall, or in summary, exploratory data analysis helps us clean, understand, and visualize our dataset. It also set the stage for accurate modeling. And once we've checked the distributions, we handled outliers, and we visualized relationships, we are now ready to move on to the next step. So the next step, actually, after performing data visualization, is ito na. We fit the multiple linear regression model. This is where we establish the mathematical relationship between our dependent variable and the predictors. So as you can see on the right side of the slide, we have here the SPSS output. Okay. So one is the ANOVA value and the other one is the summary of coefficients. Okay, let's analyze them one by one. So after performing the analysis through SPSS, again, I beg your pardon, the how to do the analysis through the SPSS is unfortunately not covered in our lecture this time. But do not worry, I will upload one video, okay, for a video on how to use the SPSS in computing or analyzing the regression model. Kasi hindi pwedeng mahirap kung by hand natin i-compute yung regression model. Matagal. Saka maraming formulas. So, mas maigi gamitan ng SPSS. Okay? So, I will create one and upload it for our consumption. Okay. So, after having the data analysis through the SPSS, ito yung lumabas. Okay, let me explain to you ano ang mga ito. So we have here the final model with respect to the relationship between the y variable or final grade and the three independent variables. So the final model reads y is equal to 60.236 plus 0.167 SH. SH is stands for the study hours plus 0.299 AR. AR is the attendance rate plus 0.012 SS. SS is the stress score of the students. Okay. So saan galing mga ito? So kung makikita nyo dito sa second table, dito sa coefficients, yung 60.236 ay yan yung coefficient dito under the first column, under the B column. Okay? So yan yung first value na yan, constant, yan yung value dito. And the second value which is approximately 0.17, yan yung value ng study hours per day. Yan. And we have attendance rate is 0.299. Yan din yung value doon, 0.299. And the same is true with the stress score. Yung value doon sa table, yun ang gagamitin mo sa model na yan. So the value from the table, you get this value, then adapt it to the equation to come up with the multiple regression model showing the relationship between the final grade and the dependent variables. Okay. So first, let us discuss this. The intercept. Okay. So the first is the intercept, which is which is 60.236. Ano ito? This is the constant term. It means that if all other variables, study hours, attendance rate, and stress score were zero, the predicted grade would be 60.236. Okay? Kung zero, halimbawa, in the actual, okay, in the context of our example. So halimbawa, zero yung study hours ng student, zero yung attendance rate, zero din yung stress score niya, ang grade ng bata ay 60.236%. Yan yung grade niya. Kung zero lahat yun, yung independent variables. Yan ang ibig sabihin nun. Now, study hours, which according to the table is 0.167. Okay? Ang ibig sabihin nito, for every 1 hour increase in study time per day, the student's grade is expected to increase by 0.167 points. Okay? Bakit increase? Kasi positive yung sign doon sa student hours. Okay. Next, the attendance rate is 0.299. So, ang interpretation niyan is, this coefficient tells us that for every 1% increase in attendance rate, the student's final grade is expected to increase by 0.299 points. Okay? Positive din kasi positive yung nasa table natin. Attendance appears to be the strongest predictor among the three, meaning students who attend classes more regularly tend to achieve higher grades. Yan ang interpretation yan. Eh, parehas din doon sa, yan din ang interpretation doon sa study hours. Okay? The more you study, of course, the more chances of obtaining a higher grade. Kasi positive nga, positive correlation. Now, for the stress level, for the stress score, which is 0.012, this coefficient is is very small, indicating that the stress level has almost no effect on the final grade. In fact, when we check the p-value, it's 0.921 for above the zero point 0.5 threshold, meaning stress is not a significant predictor of final grade. So, saan niya nakuha yung bakit hindi daw? Sabi niya dito, the stress score is not a significant predictor of final grade. Because kung titignan niyo dito sa last column, the p-value is more than 5%. Okay? Na-discuss natin yan when we had sa discussion natin ng correlation. Parehas din dito. If the p-value is more than 0.05 or 5%, the correlation is not significant. So kung makikita natin, comparing the three, ang significant predictor of final grade is attendance kasi less than 5% yung p-value. And the other two, study hours and stress score, have p-values of greater than 5%. Therefore, we can conclude or we can say that study hours and stress scores are not significant predictors of final grade. It's only the attendance rate na significant yung predictive power niya. Okay. Now, let's discuss anong interpretation or anong ibig sabihin ng first table. Yung, we call it the ANOVA table, ito sa taas. Okay. This coefficient, or looking at the ANOVA results, the p-value is 0.15. Itong last column natin. I hope you can see. Yan, yung nakikita natin, 0.015, which is below the threshold of 5%. Okay? Ang ibig sabihin nito, since 0.015 is less than 0.05 or 5%, ang ibig sabihin yan is that the regression model as a whole is significantly significant. Ibig sabihin, yung model natin, yung equation natin na ito, can significantly predict final grade if you combine all of these three. Okay? Now, you might be confused. Sabi ko kanina, hindi significant predictor ang stress level at saka study hours. Yes, if you take them independently, they are not significant predictors. But if you put them as one in one equation, yung tatlo na ito, then your equation becomes a powerful or becomes a significant we can use that. There is enough evidence to say that this model can predict final grade. Yan ang ibig sabihin yan. Okay? So to summarize, this model shows that attendance rate is the strongest and most significant factor affecting final grades, while study hours have a weaker effect and the stress score has no significant impact. Overall, Our model is statistically significant and helps explain variations in student performance. Okay. So again, the while study hours and stress score are not significant predictors to final grade, but if you put all the three in one equation, then the equation becomes uh, fitting or okay, or it fits the data. We can use it to predict final grade. So ito yung basis natin for saying that the model is a significant predictor of or the model fits the data. Okay. So we can use it to predict final grade. Now let us interpret the third. Actually, there are three tables. There are three tables to consider dito. One is that will be shown in the next slide. Yung determination of uh, coefficient of determination. Okay. So I think na-discuss na natin ito, how the values of the ito. Okay, so study hours, ito yung interpretation niya. That is for every hour increase in study hour increases the predicted final grade by 0.167. Likewise with attendance rate, pag in-increase natin yung attendance rate ng 1 point or 1%, tataas yung final grade ng 0.299. And likewise with the stress score, pag itinaas natin ng 1 point, yung stress score, tataas din yung final grade ng 0.012. Now, let's talk about the R squared or the coefficient of determination. This is also very important in as far as analyzing the relationship between the dependent and independent variables is concerned. Kailangan nating interpret din ito. Okay? Kasi kanina, ang sinagot lang natin is gaano kalakas yung tatlong variables as predictors. How strong are they in predicting final grade? Dito naman, tatanungin natin kung ilan ang kaya niyang i-account. How many percent the three variables can account for the variation in the final grade. Okay? So as you can see on the table, we have here the R squared value, naka-encircle ng red. Ito, titignan natin. This is 0.129. But usually in APA format, we use the percent equivalence. So that would be equal to 12.9. Okay? This value represents the proportion of the total variance in the dependent variable that can be explained by the independent variables study hours, attendance rate, and stress score. This means that about 13% or roughly 13%, malapit lang naman yan, 12.9 is approximately 13% of the variation in students' final grades can be explained by these three predictors when combined. In other words, our model explains a small portion of the total variation, suggesting that other factors, ilan yung other factors? Kung 13 yung kaya ng tatlong variables, yung natitirang 87% are coming from other factors. So these are external factors not included in the model. Of course, we can say na marami namang factors na pwedeng mag-effect ng final grade, di ba? aside from attendance, aside from stress level among the students, study hours, catering study habits. Study habits can also affect final grade. What else? Okay, teachers factor. Yan ang yan ang pinakamalala. Yan is teachers factor. But then again, unfortunately, they are not included in our they are not included in the model. So kabilang sila doon sa 87%. Okay? So kung halimbawa this is a study na if you are undertaking a similar study, 'yon ang pwede niyong ilagay doon sa limitation. Okay? So your study, you could recommend to future researchers na to consider other factors affecting final grade aside from what you have already included. Okay? Pwedeng ilagay niyo doon sa limitation niya or sa recommendation. Okay. So, okay, so we have here the model fit assessment. The coefficient of determination R squared is 0.129. Attendance rating is a significant predictor. Okay. Dito naman, I think we've already discussed this earlier, yung ano ang nilalaman ng table na to. Okay, so that this table here, the second on the right, okay, this will tell us the coefficients of the individual independent variables and their p-values dito sa the last column. So actually, ditong table na ito, ang kailangan lang natin is the first column and the last column. Ito lang ang kailangan nating interpret. Okay. Okay, so meron na tayong analysis, meron na tayong results, meron na tayong results or we simply call it the findings. Ito na yung findings natin. And to put it in a uh, formal writing, okay, siyempre yung ginawa natin kanina, na-chop-chop yan, let us now put this in one paragraph. And we call this the reporting the result, or this is the findings actually. And we followed this is how we do it in APA format. Okay, this is how we do it in APA format. So let me just explain to you. Anyway, nababasa niyo naman dito. So ang ibig sabihin nito is that we conducted a multiple linear regression analysis that is to predict students' grade based on three predictors. We have study hours, attendance rate, and stress scores. Okay. Ano ang nakalagay dito sa report natin? The model significance. It is very important that we mention the significance of the model. Okay? The overall regression model was statistically significant with F. F stands for the F test, the Fisher test. 3 is the degrees of freedom, and 80 yung nakaloob doon sa parenthesis, yung first number na 3 is the degrees of freedom, and 80 is the number of respondents. So F 3 and 80 is equivalent to or is equal to 3.7, that is the F value, and the P value is less than 5%. This means that collectively, the three predictors explain a meaningful portion of the variability in students' final grades. Okay. Another thing that we included in the reporting the result is the variance. Okay, the model accounted for 12.9% of the variance in final grades. That can be expressed in terms of the symbol R squared. Okay, after adjusting for the number of predictors, the adjusted R squared dropped slightly to 0.094, which is typical in the smaller models. This tells us that while the model has a significant overall fit, it explains a modest amount of the total variation in students' performance. So, ibig sabihin, while the model is significant, medyo maliit, basit pa lang diyan, 9%. So, now let's look at the individual predictors. So, kailangan din ilagay natin yung individual predictors doon sa report natin. So we have to report the attendance rate, which had a standardized coefficient of 0.352 and a p-value less than 5%. Okay. This means it is a significant predictor of students' final grades. Another thing that we should include, hindi lang yung uh, the hindi lang yung dependent variable, but we have to include all the independent variables. So in simple terms, ang ibig sabihin ng report na to, our results suggest that students who have higher attendance rates tend to achieve higher final grades, even when controlling for study hours and stress levels. The overall model is statistically valid but modest in its predictive power, meaning that while attendance matters, there are likely other factors beyond these three that also influence academic performance. This finding highlights the importance of promoting regular attendance as a key academic strategy. So tama lang tayo. We are strict with attendance. Teachers and administrators may implement attendance monitoring. Itong sinasabi ko, ito yung implication. So kailangan ito sa when you will be having your thesis later, by all means, you follow the 3 to 4 levels of interpretation. So, yung naka-flash dito, ito lang yung findings lang yan. Itong sinasabi ko, ito yung mga interpretation saka implication. Okay? Ito yung implication niya. So the model overall is statistically valid but modest in predictive power, meaning that while attendance matters, there are likely other factors beyond these three that also influence academic performance. This finding highlights the importance of promoting regular attendance as a key academic strategy. Teachers and administrators may implement attendance monitoring and incentive programs to enhance engagement and learning outcomes. Additionally, although study hours and stress levels did not emerge as significant predictors, in this case, they remain important areas for student support and further investigation in diverse learning contexts. And as we wrap up this presentation on multiple linear regression, let's reflect on the key takeaways from today's session. So number one, quantifying joint influences. Regression allows us to examine how several variables work together to explain an outcome. Instead of focusing on one factor at a time, it helps us see the combined effects of multiple predictors. Second, partial effects matter. Each coefficient tells us the unique contribution of a variable while controlling for others. This is what sets multiple regressions apart. It isolates the specific impact of each predictor. So while we use independent variables collectively in a regression model, the individual effects of each should also be taken into consideration. And the third one is that assumptions are critical. The validity of our results depend on meeting assumptions like linearity, independence, homoscedasticity, and normality. And of course, ignoring this can lead to misleading conclusions, no matter how significant the p values may be. And finally, the practical applications of MLR. Multiple regression is not just a statistical exercise, it's a decision making tool. Whether we are studying academic performance, predicting business outcomes, or evaluating behavioral patterns, regression helps us make evidence based inferences and informed decisions. This is our presentation. Thank you, everyone, for your attention and participation throughout this lecture. And if there's one message I'd like you to take with you, it's this: regression is not just about numbers. Take note, it's about stories hidden in the data. Every coefficient, every pattern tells us something meaningful about the world we study. Once again, thank you for joining today's session. And I look forward to seeing how you apply these concepts in your future researches.